This tutorial is a basic introduction to the fundamental tools and principles used to design a printed circuit board or PCB using Altium Designer. The version of Altium used to develop this tutorial is Altium Designer 10. This tutorial assumes the user has experience using Windows-based operating systems. Throughout these tutorials, a left click on the mouse is indicated by an animated red ring spreading out from the mouse pointer. A right click is indicated by an animated dimple push into the screen. This chapter of the tutorial instructs the user in how to use the PCB editor within Altium Design. The PCB document is where the physical PCB is designed. Altium uses the schematic document to work out which component bodies are required and which pins are connected together. However, it is up to the user to physically lay the components out in a usable manner and lay the tracks out appropriately in a way which avoids electromagnetic noise and inefficiencies. To move a component, the user simply has to click, hold and drag the component. When the component is in the correct position, the user can release the mouse button and the component will drop into position. While the user is dragging any component, they can press the spacebar to rotate the component for print by 90 degrees. Also, while dragging the component, the user can press the Tab key to access the component properties. Zooming in on the PCB document occurs in the same way as the schematic document. Pressing page up will zoom in on the PCB document. Pressing page down will zoom out. Holding Control on the keyboard and scrolling the mouse button will also zoom in and out. Double-clicking on a stationary component will open the component's properties. The component properties can be used to position a component accurately or to change the layer on which the component sits. The board options are used to set the measurement units, grid sizes and other parameters used in laying out the PCB. They are accessed by clicking on the menu bar, Design, Board Options. The component placement grids can be changed regularly to allow for easy, precise and uniform layout of the circuit board. The user may wish to alternate the measurement units of the document depending on their preference or how an application note for a particular component is written. Clicking the OK button will apply the settings to the document. The grids can also be changed using the Grids tool on the toolbar. The next step is to set up the design rules. This should be done before positioning any components or laying any tracks, as it assists the design process greatly. A separate document lists some of the general values for the design rules and explains how the rules affect the PCB. The design rules are accessed by selecting from the menu bar, Design Rules. This brings up a window with a list of all the design rules from the left-hand side. Expanding the individual rule groupings will display the number of rules under each category. Please refer to the separate document for a list of appropriate values for these design rules. When the user is finished editing the design rules, they should press the Apply and then the OK button. Initially, if no components are laid out on the board and no tracks placed, then there will be very few design rule violations produced. When an object violates a design rule, it is highlighted in a bright green color. When a circuit has to fit inside an enclosure, it is common for the enclosure designer to dictate the space constraints of the system to the PCB designer. The enclosure designer will usually specify the size of the circuit board and how it will be mounted within the enclosure. This can often be a difficult constraint for the circuit designer to work within, and it is important to establish whether or not the circuit design is possible within this constraint at the earliest stage. Both the area of the PCB and the height of the attached components are important considerations for the PCB and enclosure designers. The outline of the PCB is drawn on the Mechanical 1 layer. The different layers available in Altium are listed as tabs at the bottom of the PCB document. Each layer in Altium has a different function. Connections between component pins are drawn on the top and bottom layers. Mechanical one is reserved for physical attributes of the PCB, like the PCB outline and the 3D bodies of the components. Top overlay is used to display component positioning information and designators on the top layer of the PCB. Bottom overlay is the bottom layer equivalent of this. Multilayer is for connections that pass through every single layer of the PCB. The keep out layer is used to isolate areas of the PCB that should not have any electrical connections. For example, if a part of the enclosure passes close to the PCB, the designer may wish to keep this area clear of components, so they would use a keep out line to isolate that area of the PCB. The user can switch layers on and off by accessing the Layer Manager window. This can be found by clicking on the menu bar, Design, Board Layers and Colors, or by pressing the letter L on the keyboard. Here the user can show and hide entire layers as well as enable new layers for different purposes. To draw the outline of the board, select the Mechanical 1 Layer tab. From the Utility Tools menu on the toolbar, select Place Line. Make sure that Place Line is used, as this will draw the outline on the correct layer. If interactively route connections is used to draw the board outline, Altium will attempt to draw on a tracking layer, and this is incorrect. Starting at any point on the PCB document, click once and a pink line will start to be drawn in either the X or the Y plane. Clicking a second time will fix the line, creating a waypoint. The line will then try to angle away from this point at 45 degrees. If a 90-degree angle is required, pressing spacebar on the keyboard will facilitate this. The user can continue to perform this technique until the rough outline of the circuit board is complete. There should be no gaps in the outline and no tails on any wires. The user should select the entire outline of the PCB either manually or by using Find Similar Objects, as mentioned in the Schematic Editor tutorial. With the outline fully selected, the user should select from the menu bar Design, Board Shape, Define from selected objects. The black grid area will be cropped down to the size of the outline of the PCB, which helps clearly define the workable area. The origin is a point of reference for any measurement related to the PCB. It often helps to set the origin to the bottom left-hand corner of the PCB so that distance calculations can be accurately measured, although moving the origin regularly throughout the design process may assist with component placement. Click on the menu bar, Edit, Origin, Set. The mouse pointer changes to a crosshair, prompting the user to click the new location of the origin. When the user clicks the screen, a round circle with a diagonal cross through it appears as part of the grid system. This indicates the origin point. The XY coordinates of the mouse pointer's current location are always displayed in the bottom left-hand corner and are measured in the document's native units relative to the origin. By double-clicking a line from the board outline, the user can view and edit the line's properties. This is the most precise method of setting the dimensions of the line. The dimensions are defined using the document's XY coordinate system to set the start and end point of the line. Using this system, the user can accurately define the start and end point of each and every line of the board outline to give the PCB accurate shape. The coordinate system can also be used to accurately place mounting holes and any other physical structures on the PCB. The user should place mounting holes onto the PCB at the start of the design and lock them into place so that any subsequent design work takes account of the mounting holes and other structures. There is nothing worse than completing a complicated PCB and then having to rework it because mounting holes have been forgotten about. To place a hole, select Place Pad from the toolbar. A hole will be attached to the mouse cursor. Before placing the hole on the board, the user can press the Tab key on the keyboard to edit the properties of the hole. In the Properties window, the user can edit the shape, size, and pad properties. Setting the properties before placing the pad has the advantage that all consequent pads will be placed on the PCB with the same dimensions and will not need to be changed individually afterwards. When the user is happy with the hole dimensions, they should close the Properties window by clicking the OK button. With the hole still attached to the mouse cursor, the user simply has to maneuver the mouse pointer to the approximate desired location of the hole and click the mouse button once. This will lock the hole in position. The hole template is still attached to the mouse cursor so that the user can place other holes onto the PCB. Once the user has finished placing holes, they simply need to right-click and the hole placement tool will close. If the user wishes to place the hole more precisely, they can edit the XY coordinates of the hole by double-clicking on the hole and changing the coordinates in the Properties window. The user can still edit the size and shape of the hole if they so desire using the Properties window. Holes can be connected to a particular net on the circuit board, although the user should give strong consideration to grounding issues before doing so. There are many different techniques for laying out a PCB. One commonly used method is to place the components in a similar fashion to the layout of the schematic and piece the component sections together in a way which reduces the track lengths as much as possible. Altium already knows which points are to be connected together and indicates this with a thin, straight grey line. This line will indicate the shortest distance between 2 points, ignoring component bodies and other tracks. Care should be taken to avoid introducing electromagnetic interference into the circuit by avoiding placing tracks and ground planes near noisy components such as cords, oscillators, high-power MOSFETs, and motor controllers. Application notes for critical components often provide advice on how to lay out the components and include information on distances and spacing. It is often forgotten that components can be placed on both the top and bottom layers of the PCB. This technique can be used to save space. It can also be used to place tall components on one side of the board and low-profile components on the other. This can be effective if physical space is restricted within the enclosure of the product. The most common tool used to route tracks between pins is the Interactively Route Connections tool located in the toolbar. Altium has an auto route function that is a highly useful tool. However, the use of auto route requires in-depth knowledge of PCB routing and the rules must be set very precisely. The use of interactively route connections is highly recommended for inexperienced users of Altium until they develop experience of PCB design. Before selecting this interactively route connections, make sure that all the components have been carefully placed on the PCB in an efficient manner. The user should select the layer on which they wish to place the track using the layer tabs provided at the bottom of the document window. It is recommended that if the PCB is to be manufactured professionally, the user should place the majority of tracks onto the top layer and use the bottom layer for a ground plane. If the PCB is to be manufactured within the University of Queensland, then a different set of rules apply. Please refer to the ETSG website for a list of design rules. It is recommended that the user starts tracking the shortest wires first and leaves the longest ones to last, especially the VCC connection and the ground connection. The ground connection is often not tracked at all, but is connected by means of ground plane. Ground planes will be covered in a later topic in this tutorial. Once the user is ready to place tracks, they should click the Interactively Route Connections tool on the toolbar. A crosshair will appear on the mouse cursor. If the user holds the crosshair over the exact center of a component pad, then a small circle will appear. This indicates that any electrical connection will be made to the exact center of the pad. Clicking on the pad will start the track. If the track is on the top layer, it will be colored red. If it is on the bottom layer, it will be colored blue. Other layers use other colors to distinguish them from each other. The track will follow the direction that the mouse pointer leads it. If the direction is not what the user desires, then they can change it by pressing the spacebar on the keyboard. The user will notice that the grey line directly connecting the 2 points will shorten as the track gets closer to its destination. The user can click on the PCB anytime they wish to change the direction of the track. This establishes a waypoint in a very similar fashion as placing a wire on the schematic document. Pressing the asterisk key on the keyboard will place a wire on the PCB and the track will change from the top to the bottom layer or vice versa. A wire is simply a plated hole through the PCB which connects the top layer to the bottom layer. It is often a lot smaller than a component pad or mounting hole. It is common to use a wire in the routing of long tracks across the board, as long tracks will encounter more obstacles. Once the user reaches the destination pad, they simply need to click the center of the pad to make the electrical connection. The track will continue to track until the user clicks the right mouse button once. The user can continue to route other tracks by clicking on a new pad and guiding the track as before. Clicking the right mouse button twice will cancel the Interactively Route Connections tool completely. Any incorrectly placed track can be removed by clicking on the track to highlight it and then pressing the delete key on the keyboard. There is also a tool in the menu, Tools, Unroute, that allows the user to unroute a connection between 2 points, a complete net, an entire component, a room, or all the connections currently routed. The ground or 0-volt connections should be the very last connection left to route. This is normally handled by means of a ground plane or a polygon plane. A ground plane is an internal layer to which all grounds are connected. If the user does not want the expense of complexity of using a ground plane, they can use a polygon plane to connect all the ground points together. If the majority of tracks are on the top layer, then the polygon plane should be placed on the bottom layer. This will help ensure that the polygon is as non-fragmented as possible. Before undertaking this step, it is recommended that the user increases the clearance design rule so that there is increased clearance between the polygon pool and any other net. Next, the user should select which layer the polygon plane is to be placed on using the layer tabs at the bottom of the document window. Now the user can click the Place Polygon Plane tool located on the toolbar. A window will open asking the user to input the parameters of the polygon plane. The most common settings are Fill Mode, Solid, Name, Ground or 0 volts, Layer, Bottom layer, Lock Primitives, Checked, Locked, Unchecked, Ignore online violations, Unchecked, Connect to net, Ground or 0 volts, Pour over all same net objects, Remove dead copper, checked. All other settings should be left as a default setting. When the user is happy with the settings, they should click the OK button. The mouse pointer cursor will change to a crosshair, indicating that the user is being prompted to click a starting point on the PCB. The user should click in a corner of the PCB and continue clicking in each corner until all corners have been clicked. The user will notice a line extending between the waypoints, showing that a polygon is being drawn. When all the corners of the PCB have been clicked, the user should right-click and Altium will draw the polygon shape, connecting it to the ground connections automatically by way of a cross-shaped connection. The user should check the entire polygon plane to make sure that it is not fragmented and that there are no narrow necks that could possibly fuse if high currents are expected throughout the circuit. In particular, the connection surrounding the point where the ground is connected to the PCB should be checked to make sure there are strong connections. This point could be where the connector for the battery is located or the connection of the regulated power supply. If the user is happy with the ground polygon pour, then they should change the clearance constraint back to its original setting and check the PCB connection. It is common for designers to place descriptive identifiers and dimensions onto the PCB in order to control the revision of the board and identify it within the design system. Text can be placed anywhere on the PCB and on any layer depending on how the user wishes the text to be displayed. To put descriptive text onto a layer, the user must first select the layer on which the text is to be placed. The most common layer on which to place descriptive text is the top overlay layer or even the top layer of copper. Click the Place String tool and a string will be attached to the mouse cursor. The user can press the Tab key to alter the properties of the string before they place it on the PCB, or they can click to place the string onto the PCB and then double-click it later to open the properties. Right-clicking will cancel the Place String tool. To place dimensions, the user should select the appropriate layer for placing dimensions onto the PCB. This may be one of the mechanical layers, for example, Mechanical 2. The user should then click the Place Standard Dimension tool located within the Drawing Tools palette on the toolbar. Altium places a dimension onto the mouse cursor, prompting the user to click the start point of the dimension that they wish to measure. The user should click once on the point that they wish to dimension and then move the mouse to the end of where they wish to finish the dimension and click again. Altium will automatically calculate the dimension in its native units. The user should now have a PCB that is completely finished and ready to send off to the manufacturer. Most manufacturers will be able to read the Altium PCB doc file directly and can use this to manufacture the PCB. This concludes the PCB document section of the Altium tutorial. There is one further tutorial which details how to create custom components within Altium. However, this is considered to be an advanced topic and is not essential if the user has a strong grasp of how to use Altium's inbuilt component libraries.